Okay. Good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. I will be discussing tonight how we protect light-emitting diodes from immediate burning if we are using this one as a voltage indicator. So what I did was to connect in series a resistor around 820 ohms with the light emitting diode to limit the current passing through it. Because if the applied voltage on the light emitting diode is big, maybe 12 volts, like this one here, the voltage applied on the light emitting diode is 12 volts. The current consumption is 120 milliamperes with a series resistor of 820 ohms. But without the 820 ohms, okay, with this 12 volts applied, okay, it will not last long. It will get burned. So to protect light emitting diodes from immediate burning, which serves us as an indicator for voltage indicator for DC voltages, okay, we must have to connect in series with the light emitting diode at least an 800. I was supposed to put a resistor here 1K, but I don't have a value, and the nearest value I have there is actually 820 ohms. So 820 ohms will be fine. For this, if you try to fill the light emitting diode, it's not hot because the current passing through it was just good enough for it to be lighted. But just in case the resistor is actually not connected in series with this one, as soon as you apply 12 volts over here, okay, the current might not be 120 milliamperes. It might be big one, maybe more than 1 ampere maybe. If the current is more than 1 ampere, okay, immediately this light emitting diode will get burned. So to protect our light emitting diode, which serves us as a voltage indicator for DC voltages, we must have to connect in series a resistor, at least a 1K, okay, 1000 ohm resistor in series with it to limit the current to, like this one, if the applied voltage is 12 volts, the current consumption of the light emitting diode, of course including the resistor, is 120 milliamperes. If you try to see it, if I will try to increase this one, okay, I increase this one, I increase the applied voltage to the light emitting diode, it's still fine. It does not get burned, but the current goes up to 140 milliamperes. But without this resistor here, which is connected in series, immediately, okay, this light emitting diode will get burned. So it's a must for us who are troubleshooters or electronic enthusiasts or troubleshooters. It's a must that we must have to connect in series with the light emitting diode a resistor which limit the current passing through it. Because the important thing here is that at least we could say that the light emitting diode is lighted, meaning to say the voltage we are monitoring is actually alive. Okay? Like this one now, if I will try to increase this one to 14 volts, you see, the current consumption is 150 milliamperes, but the light emitting diode is still alive. It's still very cold. Okay? Because without the resistor which is connected in series, immediately it will get burned without it. So it's a must that we must have to connect in series with this light emitting diode a 1K resistor to limit the current passing through it and for its life to be long life. Okay, if I will try to listen this one, the applied voltage, you could see that the current consumption is going down. Okay, so it depends on the value of the resistor. Even though we decrease the value, the light emitting diode is still lighted, meaning it is indicating that the voltage 10.2 is alive. That's the important thing there. Okay, if you feel the diode, it's very cold, right? That's a 90 milliampere. Okay, good evening, Los Angeles. I think this is a good concept for those who are trying to learn electronics. It's a must that we should know how to protect our light emitting diode, which serves as our voltage indicator for direct current voltages if we are working on direct current circuit. Okay, good evening from Los Angeles. This is Professor David J. De Los Reyes.